For the video today, we are going to discuss how to use the standard normal tables to find the probability. Okay, so we can have a look for the learning outcome for today. So for learning outcome for today is we need to learn how to solve the problem which is normally distributed. And after that, you also need to know how to use the table to find the value for probability. Okay, if let's say you are given the value for mean and also standard deviation. And after that, you need to find out the mu and standard deviation if, let's say, some probability are given. All right, so all these are the learning outcome that you must know after you go through these few videos. All right. Okay, so let's start with the first one. Previously, we already discussed in the previous video, we already discussed some very basic properties about normal distribution. Okay, so usually for normal distribution, if you want to find out the value of probability, you need to use the table to find out. There's no other way. Okay, so to find out, you need to have the table. So the table will be provided in the formula booklet. And then later I will teach you how to use the table. All right. Okay, so let's go through with some very basic details first. Okay, so first of all, when you are having a normal distribution, if you want to find out the probability x equals to any number a, it is always equals to 0. Only for normal distribution, binomial, geometric, all got value 1. Just that for normal distribution, when x equals to 1, x equals to 3, x equals to 2.5, always equals to 0. Okay, and then after that, you also need to know that when we want you to find the probability for x smaller than x1, the value is also the same as x smaller equals to x1. These two symbols have the same answer. Okay, so we are not going to bother whether the equal sign or no equal sign. In short, that means they are both the same. All right, but for Poisson, for binomial or geometric, they are different. There are not, there are differences between these two. But for normal distribution, they are the same. Same value, same answer. Okay, same thing happens for greater. If let's say I'm having x greater than 2, the answer is the same as the probability of x greater equals to x2. All right, so let's say x is between these two numbers, x1 and x2. The answer will be the same as the probability between an inclusive x1 and x2. Okay, so this is a small properties that you need to know for normal distribution. Okay, all right. So in exam, don't ask me again. Can I write like this? Can I write got equal sign one? Can I write no equal sign one? No matter you write equal sign or no equal sign, they are the same. No difference. All right. Okay. Then after that, the standard normal variable is given the special symbol z rather than x. So we call it as standard normal. Because on the table provided, right, there are only one table provided for the normal distribution. So we already standardize it. So the standardized normal distribution, the variable we call as z. So for z, it is normally distributed. Standardized, after standardized, the mean is always a 0, and then the variance is always a 1. Okay, all right. Then when you go through with our syllabus later, or maybe some marking scheme, you will see that you always see this symbol called as phi. Right, so phi z, the meaning is z smaller than the value of z. Okay, usually I prefer to write it in this formula or this pattern because I can see clearly what's the meaning. If let's say you never learned this before, right, you might not know what's the meaning of this. Okay, so usually when I write out, I will write out these two. Either one. Okay, I don't like this symbol because to me this symbol, I actually don't really, some students or maybe some people will not know what is the real meaning of it. They didn't learn it before. All right, so but just in case if you see any marking scheme or any reference book, they write you this symbol, generally it means that x smaller, z smaller than that. Okay, all right, so now there are some important results here, but generally I will ask students if can, when you want to find the probability, no need to purposely go and memorize the formula. All this formula, to me, no need to memorize one. I will usually use a graph to help me to understand it. Okay, so later when I explain to you, I will also use graph. Right? Okay, then I'm not sure what is the version of the notes that you get here. Okay, can you have a check in your notes? Yours one is this one greater or smaller? If let's say it is smaller, change it become greater. I make a typo before, but I'm not sure whether for your for your notes. What kind of version are you having? Alright, so just make sure this is greater sign. And after that, another one is this. Please check and see the modular sign is at X or is at A. If let's say it is at A, that means it is wrong. It should be at Z. Modular Z smaller than A, modular Z greater than A. So these are the typo that might appear in your notes. So if let's say your notes one is not like this, then please change it to this one, correct one. This is the correct one. Your notes one might be the wrong one. Okay? Right. So now, usually when students ask about this formula, right, I will tell them no need to memorize it because actually it's very simple, only all this formula. Okay, but if let's say you really want, what you might need to remember is this and also this one, the modular sign. Without modular sign one, generally no need. Okay, all right. And also part number 4, also you might need to know if let's say you can't really understand a graph, but to me all this can understand by using a graph. Okay. Excuse me. All right, so now let us go and have a look at how are we going to find the table, the probability from the table. Okay, so now, first of all, if let's say, maybe before you go through with this example, you can prepare your own formula booklet first. Maybe a hard copy is good so that you can refer to it when I talk about it. Right, so now, if let's say I want you to find the probability Z smaller than 0.16, how can you get the value from the table when we are having smaller sign? Okay, so now I will share another file with you. Okay, so this is this part actually consists of 2 tables. So before I teach you how to use our normal distribution table, right, I would like to show you what is the difference. Okay, because I believe that some of you are from SPM background one, you actually learn normal distribution before. Okay, and then there's one important thing that you need to know. The table on top here, this table, I just take out part of it. I didn't take out the whole table. I just take out part of it. This table is SPM normal table. Okay, so the bottom one here is the A-level normal table. All right, okay. Then what's the difference between these two? If let's say you look at the A-level normal table, they actually want the value that they give you in the table is left-hand side value. That means the answer, the probability that you get is on the left for a particular value. Okay, and for SPM, the value that they provide in your formula booklet is actually on the right-hand side of the value. So actually, they are actually two different, totally different tables. Okay, so last time you learned is for greater one, but now you are going to use the smaller table. Okay, so as an example, if let's say I want you to find out the probability Z smaller than 0.16, okay, so when the 0.16, this kind of value, you will look for all the value outside and beside, on top and beside. So the same thing happens here. All these are the value of Z. Okay, and then the answer that you get, you will get it from here, all this part. Okay, so the same thing happens for A-level table. Yeah, all right, so now when we are talking about 0.16, so what is the 0.16? How can I read the value? So usually for 0.16, you look at 0.1 and then 6. So 0.1 is here, right? And then 6. Okay, so this is the value that we have in SPM table. All right, but if let's say we look for the A-level table, 0.1 is here, and then you look for the 6 here. So when you read the value, so this is the value. Okay, all right. So if you compare these two values, you'll see that these two values are different actually. But when you add them together, it is equals to 1. That means they are totally two opposite table. Understand what I say or not? Okay, this one is looking for greater. So this value is actually probability Z greater than 0.16, and you get 0.4364. So last time in SPM, this is what you are doing. Okay, but for now, in A level, if let's say I want you to find out Z smaller than 0.16, then the value that you get should be this one. So 0.5636. Okay, so you need to use some time to get used to this new table, because A level SPM table are totally different. It's opposite one. Understand what I said? Last time when you learn, you are learning all the probability for greater than a value. But for A level table, we are finding the probability which is smaller than the value. So remember that. Okay, so if let's understand this new table, right, then generally all the concept that you learn in SPM can apply it here. Okay, the only difference is the table here. The table is totally different. So some students might need some time to get used to it. Alright, okay, so this is the difference between SPM and also A-level table. So make sure you know how to use this A-level table. We are talking about Z smaller than a particular value. Okay, alright, and we are talking about the area on the left-hand side of that particular value. Alright. Okay, so if no problem, then we go back to our notes here. So again, I need to share back our notes. Alright, so like example 1 just now, the value that you get is 0.5, sorry, 0.5, what? 5636. So 5636. So if you want to make it on to be on the safe side, right, you can change it become 3 significant figure, which is 0.567. Right? Okay, so if let's say you want to get the value for Z smaller than 0.345, also very easy. You look at 0.34, and after that, at the end of the table, you look for the find. Okay, so another differences are between the SPM and A-level table, and I forget to mention it to you just now. All right, so share back the table. Okay, so I hope that you can see the table now. All right, so I erase all this first. Alright, so just now what they want is 0.345, right? Okay, I'm looking for the probability smaller than 0.345. Okay, so because now I want to use the table, so I will just focus on A-level one. Okay, so where is 0.3? Okay, so 0.3 is here. Then the 4 is here. So you read for this value first, which is 6331. And after that, where can I get a 5? 0.34. 5 is at the end. 5. Okay? Alright, so now there's another differences between the SPM and A-level table is this one. For A-level table, we are going to add the value shown, but for SPM last time you are subtracting the value. So you see the difference again, huh? Alright, okay, so now if I want to get a value for 0.345, okay, so the 5 is here, right? 19. So that means what? That means for the 6331, you add 19 to it. So you have 6350. So the answer for this will be 0.6350. Okay? So again, because the table is looking for the smaller value, so you see our question is also smaller one, smaller than 0.345, smaller than 0.16, and so on. Okay, so please take note on these differences again. All right, for SPM is subtract, but for A-level table is add. All right, therefore I will get 0.6350 for our example. Okay, so this one should be 0.635. Okay, all right. So for those of SPM background one, please make sure that you get used to the new table here, the A-level table. All right. Okay, so for part number 3, you can try on your own. 0.429. What is the value for 0.429? What is the value for Z smaller than 0.429? Okay, so maybe you can try out on your own and see. What do you get? You should get 0.666. If I didn't do careless mistake. Okay? All right. So this is how we use the A-level normal distribution table. Okay, so these 3 examples are very basic, just to guide you how to do it, only how to find out the value. Okay, and then you realize that all equations here are smaller, 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 and smaller. Okay, in exam, definitely they won't ask only smaller one, right? So they'll ask you maybe greater lah, or maybe between 2 numbers and so on. Okay, so how can you answer those questions? So those questions, you need to know how to sketch the graph correctly. Okay, so as an example, I just show you some very simple one. Let's say I take a first equation here. First one smaller, very easy to do lah. This one you do it yourself. How about if let's say I want to do the second one? Okay, so Z greater than 0.85. Okay, so Z greater than 0.85, but if you imagine it by using the graph, okay, the median center is always 0, the mean is always 0 in the center, and then 0.85 will be on the right hand side of 0. So this part will be negative, this part will be positive at the value. And then the sign here, greater than 0.85, tells you that the area that they want to find is on the right hand side of 0.85, more than 0.85. So this yellow colored area is the area that I want to find. But according to the normal table that we have, the table only gives you the value for this part, smaller than 0.85. So all the value given in the table is smaller one, smaller than 0.85. So to get this yellow color part, how can you get this yellow color part? You need to take 1. 1 means the whole normal table area minus the area that you get from the table. So what is the area that you get from the table? Should be 0.8023. Okay, smaller than 1.85. Huh? All right, and then by pressing calculator, you get 0.1977. If you want it to be safe, you can change it become 3 significant figure, which is 0.19. Okay, so usually in answering all these kind of questions, I'm using common sense based on the graph and find out. All right, so some students will say in the exam, can I don't draw this graph or not? Can. As long as you can imagine out, no need to draw it. But I just draw it out to let you understand. Okay? Okay, so maybe you can try another one. How about we try this part number 4? Okay, so Z greater than negative 1.377. Okay, so if let's say for this one, if I want to draw the graph, how would it look like? So again, the 0 is in the center. All right, so this is negative value. So negative value should be on the left hand side, negative 1.377. Okay, so the greater sign tells you that you want to find out the area on the right hand side of the normal table of the value negative 1.377. So this is the area that I want to find out. Okay, for this example, if you try to find out the value from the normal table, you won't see any negative value. Okay, there's no negative 1.377. You can only find out 1.377. Okay, so for all these negative value, how can we solve it for this kind of question? So again, I will want you to imagine again. Can you try to imagine if like I change this value become 1.377? Okay, change the negative become positive value 1.377. This yellow color area, same as which area? It will be the same as this one. Correct or not? Because I told you before, right? The graph of normal distribution should be symmetric, left and right. So that means if you reflect it to inside, the area for this one also the same. Okay, so that means this area is the area that I want to find out in our question. But because we cannot get the negative value from the normal table, therefore I reflect it become positive. So when I reflect it become positive, what happened is the area smaller than 1.377 is the same as this one. Okay, so if I look at this graph, when I write the step, it will be Z smaller than 1.377. So this value and this value are the same because the area should be the same. Alright, then now you're having smaller already, right? Smaller than 1.377. So this answer you can already find out from the normal distribution table. So what do you get? So the answer is here already. Okay, 0.9158. Or if you want, you can change it become 0.916. Okay, so far any problem or not? So you need to take some time to figure out how you are going to try and find out all these answers. Okay, so for 1, 2, 3, 4, 5, 6, I will leave it for you. The answer is there already. It is just a kindergarten level work. So just make sure that you take some time to figure out how to use the table correctly. So should be no problem. Okay, then I will discuss the rest of the question here. For me, I will discuss 6, 7, and 8. They belong to same type of question. Oh, sorry, 7, 8, and 9. They belong to same type of question. That means Z is between two numbers. Okay, so when Z is between two numbers, right? Again, I believe that there are a lot of different methods that you can use or different steps that you can do, but I'm just giving you a suggestion. Right, so usually when I see this kind of question, Z is between two numbers, regardless if it is positive or negative, I will always do a standard step. So the standard step is like this. Okay, I will show you maybe part 9 because it consists of positive and negative. Alright, so this is what I have. Okay, so if let's say I look at this question, Z is between these two values. So I want to know how big is my area. Okay, so maybe I can draw a graph to help me. So again, the graph is for understanding. Alright, so if you feel like you understand, you don't need to draw. So negative 2.696 and another one is positive 1.865. Okay, so the area that you want to find is between these two values. Between these two values, this is the area. Okay, so between these two, this is the area. So maybe some of you you will reflect it here and there whatsoever I don't care. But for me, I always will use this standardized method. Standard method means that no matter Z is between two positive value or two negative value or one positive, one negative or whatsoever, as long as Z is between two value, then usually what I will do is I will take Z smaller than the value at the back minus Z smaller than the value in front. Please take note that both are smaller. Okay? Please take note that both are smaller. Why? Why this is the correct step? Don't change it become larger or whatsoever. For me, I always use smaller one, smaller than this and smaller than this. Okay, so why this step is the same as the previous step? It is because of you can actually have a look for the table here from the graph here. Okay, when I say about Z smaller than 1.865, okay, so Z smaller than 1.865 is the blue color area. So blue color area smaller than 1.865 is this one. Okay, so the blue color part is this blue color line. All right, minus Z smaller than 2.696. So maybe for this 2.696, I use the green color. Okay, so minus this one. Where is this area? So this area is the area smaller than negative 2.696. So it's this one. So can you see or not? If you take the blue color area minus the green color one, you will get the highlighted area that we want, which is our question. Okay, so it applies for all the example with Z between two values, no matter it is positive or negative or whatsoever. Okay, then after I write out this step correctly, then only I will continue. What is the probability for Z smaller than 1.865? So maybe you can try to have the table by your side. Okay, so I'm looking for Z smaller than 1.865. So wait, 1.865. You should get 0.969, right? If I'm not mistaken. So for this blue color one is 0.969. Okay, then you put minus again. Okay, so what is the area for Z smaller than negative 2.696? Okay, so again, just like I told you, right, for negative 2.696, you cannot find out from the table. So you have to imagine, you know, this green color area, it is the same as what area? Okay, so you can imagine it like this. Okay, so this green color area, if I reflect it, become 2.696. So this green color one will be this part. So then when I want to find out the answer for this part, you need to take one. One means the whole table, okay, minus the area smaller than 2.696. Then you'll get a green color area that you want. Therefore, when I write it out, I will write it out like this. Okay, so for this part, it is 1 minus Z smaller than 2.696. So again, I look for 2.696. 9965. So you should get 0.9965. So the 9965 is actually this area from the table. Alright, and that's why you take 1 minus the blue color area, you'll get this. Okay, so by just simplifying it, using calculator straight away, then you can get the answer. So 0.969 minus 1 plus. Okay, so if I'm not mistaken, you should get 0.9655. If you want it to be safe, then you can change it become 0.966, which is the three significant answer, bigger answer. Right, so this is what you have for part number 9. Okay, so 7 and 8, you just do it by using the same way. Okay, I'll just leave it for you to try. So all the answers are here already. Can you see that? So any example that I skip here, that means you need to copy yourself lah. Okay, so if let's say you cannot get the answer, you let me know again. But this is a good chance for you to get used to the new table here. Okay, then now let us try the last two. When the equation involves the modulus, so what will we do? Same thing happen. I will only discuss one example, and then you try the other example yourself. Right, so maybe I try part number 10. Okay, so when they say modulus z smaller than 1.78, it actually means that the z is between negative 1.78 to 1.78. So the modulus sign here on this equation, this inequality you will learn only in A2 pure maths chapter 1. Okay, but generally when you're having modulus z, that means it is between this number, but one is positive, one is negative. Alright, so the detail of the formula we'll learn it in A2 chapter 1 pure maths. Right. Okay, so generally what you need to remember is this, no? Right, z is between negative 1.78 and also 1.78. So how can you find out this value? So again, this is 0, this is negative 1.78, and this is positive 1.78. Therefore, the area that they want you to find out is this one. Alright, so again, this example again belongs to the pattern that z is between two values. So when I write out the formula for next step, it is always standardized. Z smaller than 1.78 minus z smaller than negative 1.78. So if you can't see clearly, then I will use the color to denote it for you. So z smaller than 1.78 is where? This area. From 1.78 and then this whole area. Okay, then when they take minus the green color part, smaller than negative 1.78, so negative 1.78 is this area, the green color one. So blue color minus green color, you get the highlighted area. Okay, then after I write it out correctly, then I will straight away find it out from the table. So z smaller than 1.78. So look for the table itself, 1.78, you should get 9625. 0.9625. Then minus, okay, z smaller than negative 1.78. Again, it is very similar to the example that I discussed with you just now. So you need to take 1 minus z smaller than 1.78, which is 0.9625. So if you do it in this way, then what do I get is 0.925. Okay, so this is the example for modulus z smaller than a number. Right? Okay. Then how can I do the example with greater? Okay, so let's say I change this example become greater. Okay, so you see just now smaller, right? Just now for smaller, you will see that the area that you want to find, it become water already. Wait, So for just now example, the smaller example, the area that you want to find is the highlighted area here for smaller, which is in between. Okay, in between these two numbers. If I change my answer, my question become greater than. So when it is greater than, that means the area that we want to find out is by the side one. So I want to find out this blue color area and also this blue color area. If I change my question become greater, modulus z greater than 1.78. So this is a way that I ask my student to remember also lah. Modulus smaller than a number means it's between. the negative and positive number. Okay, if let's say greater than, means it is the side. Okay, so if you draw out the graph already, so maybe you need to remember the graph here a bit for this modulus example. Okay, so if you want to find out the area, this area, when you want to find out, when you write out is z smaller than negative 1.78. Then for this area, if you want to find out is plus modulus, z greater than 1.78. So you find out these two values separately, okay? And if you know the properties of the normal distribution, these two areas should be the same because they are symmetric to each other, right? And they are by the side, so these two values should be the same. Both are also 1.78 and 1.78. Therefore, the area should be the same. So you can write out as 2 times of 1 minus z smaller than 1.78962. Okay, so if you want to find out the answer where z modulus z is more than the number, so this is how we do it now. Okay, so 0.075. Alright, so for the next example, you try out on your own. If you want to try the smaller one, also can, up to you. Okay, so just make sure that you complete this example to all the equation here, all the example here, to make sure that you familiar with the A-level normal distribution table. Alright, okay, so I will leave it for you. The answer are already attached here, so just make sure that you know how to use it. Okay, then after that, before you end the video for today, so for this video, so we will continue with example 3. So if let's say they give you a probability like this, z greater than z2 is like this, then they want you to find out z1 and z2. Z is between z1 and z2. Okay, so now if let's say you want to find the value for z, which is between z1 and z2, so again it's between two values, right? So for the step that I do is like I always will write z smaller than z2 minus z smaller than the number in front. Okay, so how can I get z smaller than z2? They give you z greater than z2, therefore z smaller than z2 means 1 minus 0.25. A minus z smaller than z1, how can I get it? They give me greater than z. So to get this, I will need to take 1 minus 0.65. So if you do it correctly, you should get 0.4. Okay, so for this part, mainly we are focusing on, do you know how to use the table correctly? That's the first thing. And also, do you know how to use the graph, the normal graph, to find out the area that you want? Okay, but of course, you need to use both graph and table to find answer. Alright, so the graph, how to shape the area correctly. Okay, so how to reflect the area, all are very important. All these are very basic. So make sure you are really, really familiar with it before we proceed to the next part. Okay, so that's all for the video today. So for the next video, we are going to learn how to standardize our variable and also how to answer some application questions.